Good afternoon, ladies and gentlemen. So today we're going to be learning on solving a system of linear equations that are special, right? So these are very specific types of linear equations, and you have to be able to learn how to identify them and tell whether or not you're going to have one solution, right? Where you're only going to have an ordered pair where one point is where they meet, where you might have no solution, right? You have two linear equations, but they're parallel, so that means they will never touch, or you have infinitely many solutions where you get two linear equations which are essentially the exact same thing, right? They may not look the same, but when you manipulate them or change them around, you do get that they are the same equation. So you have infinitely many, right? Because there are many points that are overlapping. So let's go ahead and dissect what an example of this may look like. So here we have an example of no solution. Now, why is this an example of no solution? Because, well, look at this system of linear equations. The slope is the same, right? So remember that when slope is the same, then we actually have parallel lines, right? Now, what makes them parallel? Well, it makes them parallel because the y-intercept is not the same, right? This y-intercept would be at 1, so it starts at 1 and then it does the slope, right? So it naturally goes into the slope. And here we start at -5, and again, we just draw it along with the slope 2 over 1, right? Rise over run. And so here we have parallel lines. These lines will never touch, and therefore you will have no solutions. Now, so the first method they have, which is solved by graphing. You can do this method, right? If you want to, you can do substitution the same way that we've been working before, right? So where you replace y with each y, whichever y that you want to do. Obviously, they're the same thing. So you can replace this y with what the first equation is, which is the top one, right? So 2x plus 1. And that's exactly what they did, right? You can see method 2, and then they solve for x by, well, they subtract 2x to both sides, and you can tell right away that this will never be true, right? -5 does not equal 1. You can also do elimination, which they don't mention, right? Because you just been working on elimination. You can add these two functions, but if you add them up, you get 2y, you get 4x, right? So how do you manipulate? How do you change it? How do you revise equation 2? You multiply everything by -1, right? If you do multiply by everything by -1, here you get -y, -2x, and plus 5, right? So if you add them up, these cancel out, you get 0. If you add these up, they cancel out, you get 0. So in the end, you end up getting 0 equals 6. Now, is that a true statement? Also, it is not a true statement, right? This equation is never true, therefore the system of linear equation has no solution. You can use all three methods. This is what we've been doing all this time. We've been graphing, we've been substituting, and we've been eliminating. Now, here's an example with infinitely many solutions. So, like I said, you won't have equations that literally look the same. That's way too easy. Like if we give you the same equations, then obviously you're gonna say infinitely many solutions like in like right away, right? So we do have to manipulate these. Wow, what if you divide the second equation by 2 without even solving for y? Without even solving for y, you can already see that you're actually going to get the same equations, because if we divide -4 by 2, we get -2. If we divide 2 by 2, we get 1, which, 1 is the identity, so we just get y. We divide 6 by 2, we get 3. You get the exact same equation, right? So there's a couple methods that you can do. You can graph both of them. If you just want to plug all this into decimals and plug this into decimals, you will get the exact same line. Second method, you can use substitution, right? But substitution is going to be a problem. Well, if you want to solve for y, because y is by itself, and it's going to be a little bit more complicated, right? This time they do mention elimination. Look at that. So they changed the first equation by multiplying by -2, and here you get 4x, 2y, sorry, -2y and -6. What happens if you add these things up? You get 0 equals 0. So remember that when you get 0 equals 0, and this is always a true statement, you will get that you have infinitely many solutions. So now, what I want you to do for homework, again, I just want you to continue working on these things, because the more you work on functions, the more you work on manipulating them, the better that you will get. So what do I expect you to do? I completely expect you all to work on problems 3 through 16, all of them. Okay, so you will need to work on all of the problems. There's no odd, there's no even, all of them. So go ahead and get started on that, and good luck.